Good evening, guys, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Office. We're here to talk about service troubleshooting and diagnostic of refrigerated cases that are on racks. Um, it's Saturday night. I just got back from Oklahoma. I was up training this week, looked at some transcritical this week. We're also randomly looking at other cases. We had an instance this week. One of the cases that we were talking about, the system was a hot gas defrost, and when it went into defrost, it actually had a differential of 110 pounds between the hot gas supply and the header pressure. What was happening was someone adjusted the DDR up to about 35 pounds, which was too high for the system, as well as adjusting the holdback valve up to 185 psi. And because the condenser fan motors the pressure transducer on the discharge side controlled the condenser fan motors, what would happen was it would go into hot gas defrost, start kicking on a whole bunch of condenser fan motors, cause a hellacious differential between the discharge gas and the header pressure, which would restrict all the refrigerant from going out to the refrigerated cases and cause slow recovery in a whole bunch of cases, as well as causing other cases on the system to go in high and down. What did you have the pleasure of working on this week, Kev?
So I was actually down by you this week, all week. So I was down in Dallas helping out the branch down there with some commissioning. Me and one of my guys from Chicago flew down on Monday to basically recommission a site. Can't go into super details about it because it's a test facility, but yeah, we went there to commission a bunch of digital compressors and tune a bunch of case controllers to get as much out of them as we could so we could see how far we could push this equipment. Pretty good training opportunity for me and the guy that were there. I mean, this is something not too many people have tried to do, so we were able to pull it off, and we had to stay an extra day. We had some unforeseen things go wrong there, and a lot of iced up coils that we had to deal with. Um, Other than that, it was pretty good time. We got to enjoy some good food down by you and nice warm weather for once. And yeah, that was my day. I pretty much flew back on Thursday and just helped out with some commissioning on Friday.
And I know you can't go into like super details, but you have to share what you found with the Heatcraft coils.
So basically, we had some coils of freezer that were replaced. All of them were replaced in the last month and a half, and the entire front sides of the coils were solid blocks ice, along with the back sides, the top of the back sides were solid blocks ice. Well, we spent like 13 hours de-icing these coils, um, into the next day almost. And once we got them all de-iced, we were monitoring the system and just checking defrost temps. And I had these coils up to like an hour and a half defrost almost, and they weren't clearing the tops. So I figured we were missing a heater the way they were laid out, but the way that they were laid out from the bottom of the coil, it went heater, 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 space, heater, heater, space, space, space. So there was a straight 6 inches from the top of the coil to the next heater. So what was happening is the top of the coil wouldn't get warm enough during a defrost period to melt all that frost off. It was caused the tops of the coils to lose airflow, and it was affecting the TDs on our coils. This whole job was about getting the exact TDs out of these coils. So it was throwing off all of our calculations and everything else. So what actually happened is we figured we were missing a heater. So we reached out to Heatcraft finally. We got a hold of an engineer, and it turns out when they build these evaporators, they build them upside down. Well, their drawing is probably the worst drawing I've ever seen, because if you look at the drawing, it looks like it's correct if you were looking at building it upside down. But so they had to pull every single heater out of these things and rearrange them. And at that time, it was -9 in the freezer. So I'm glad I flew out of that. So I didn't get the chance to sit in that freezer for a day and a half moving heaters around because I don't envy those guys. That's going to be a bad one.
Yeah, at least you would have been better if you would have found it. I don't know when the box was maintaining temperature, but whatever.
Yeah, when it was 10 degrees, it'd have been a lot better to do it. So let's start to dive in on this one. We're going to go over basically how me and Brett would start a service call at a store. So this is how we walk in just about every service call we do. So as we get there, we check in with the manager, talk to them, see what's going on. I mean, they're the ones using the equipment every day, so they're the ones noticing little things. I mean, whether it's useful information or not, or they're just complaining to complain because you're there costing them money. But I mean, sometimes you may get some useful information out of them. But the way I start all these calls, I tend not to look at our dispatching software to see who was there or what's been done before. I tend to not care about that. Like I think it's worse when guys when they first get to a call, they start looking at the equipment history on their dispatching software or whatnot, because then you're just gonna be looking at what the last guy did. And if it is a callback, you don't want to do what the last guy did because you want to go in there with an open mind. So you want to go in there with an open mind so that way you could look at this from a different perspective, not on what the last guy said, because the last guy, if you're there, the last guy was probably wrong. So I generally try to not look at that stuff or not look at logbooks until I'm like further into it. The way I could look at this with an open set of eyes. So I'll go to the case first always, or the walk-in coil or whatever's running warm, and I'll take a look at it just to make sure I have airflow. I'm not ice. I'm not I don't have product sticking out of the case, and it's a product running warm coil. I'll check over the case, make sure it's not ice, make sure I don't see any weird frost patterns on the coils, make sure all my fans are working, make sure it's not a thermometer issue, check the case temperature real quick with my thermometer. You know, after that, I tend to stop doing it in the case and I move on to the rack and go to the rack controller and make sure everything is functioning properly with the rack. Everything's good up there before I go any farther and check superheats or pull strainers or do anything like that. You got anything to add to that, Brett?
No, besides not believing anybody, 'cause that's burned me more than on one occasion. Um, at least 3 times I can think of listening to a technician, even while they're on site, going through and telling you after you ask the question, "Hey, did you check the temperature to make sure it's accurate?" "Oh, yeah, we checked it, we checked it." And I started working on the case for about a good 2.5 hours, trying to figure out why this case won't pull down temperature. Keep going back to the controller and seeing what the temperature was, and come to find out that the temperature sensor was off by about 8 degrees. So that, you hit the nail on the head with not reading the service history. Too many times that leads you down the wrong rabbit hole. And you start looking at other stuff because you're reading the other service ticket. Fresh eyes is always the best. Imagine it's a brand new call. That way you're not led astray by someone else's notes.
Yeah, I 100% agree with that. I find guys all too often getting hung up on that, like especially newer guys and greener apprentices, just looking at what the last guy did. To be honest, I really don't care what the last guy did. So I think it's better to come in with a fresh set of eyes. So you want to move on to the rack part of it, Brett?
Yeah, absolutely. Um, so first off, you're going to check to make sure that the system is actually calling. Obviously, make sure that if it has an electronic EPR, the electronic EPR is actually, if it's the case is warm at that point, it should be calling to be 100% open. Um, make sure all the compressors are running and actually maintaining proper suction pressure. Typically your rack is running about 2 degrees lower than what the lowest SST is typically calling. So if your lowest SST, which you're working on, happens to be plus 18, but typically your rack should be running at around 16 degrees. And they do that to accommodate for pressure drop in the pipe. Just because you're running 18 degrees saturated, doesn't mean that you're going to be running 18 degrees saturated out at your case. because of the footage of pipe. You might have a case that has 250, 300 foot worth of pipe. Making sure that your discharge pressure is accurate and right at set point. We usually tell this to make sure that the discharge pressure is running either at the set point of that the controller is calling for. If it's calling for TD, make sure it's working properly, because having elevated discharge pressure will in fact cause your suction pressure to be elevated. Also, making sure you have a proper receiver level. Typically, I like to see anywhere from 25, 30%. Making sure you do have a full column of liquid, making sure, checking the refrigeration schedule, seeing what temperature the liquid is supposed to be entering into the TXVs. You'll usually find this under the subcooler section of the refrigeration schedule. It'll tell you 75-degree entering a liquid at the TXVs, 50-degree liquid, and just make sure that that liquid is at the proper temperature. If not, it's going to affect the sizing of the expansion valve and potentially cause that valve to be undersized and not work properly.
Yeah. One thing I want to add to that, especially with the receiver levels, being up north, you may need a little bit more gas in there. So, I mean, typically I can see like 30, 40% in full and maybe like 50 to 60 in split. Just just to make sure we have enough gas for when that coil comes out. So one
So,
thing you go ahead, bro.
sorry. Your customer spec. So the reason why I said that is because technically we usually always go by customers.
Mhm.
So for a customer down here, I'm wondering, like, for a Target up north, did they call for a receiver level as high as 60% up there?
They don't, but here's a problem. So I know it's 40 or something. I haven't done service for car in a while. I tend to be I'm tend to be more on the construction side right now, but um here's the problem. So up here, we're splitting it on splitting so much. I mean, you guys don't deal with that as much as we do. I mean, you get down there, ambient's cold every once in a while, but up here, I mean, we got the condensers just as big as you guys. I mean, everybody's been sizing everything for 110 up here for a while. You guys are obviously a little more than that, but so we get these big 10, 12 fan condensers. I mean, that thing may hold 300 pounds of gas on splits in splits. So if you're running a 25% receiver level and you go this, you go into full condenser, that's going to take like at least maybe 100 pounds of gas out of that receiver. I mean, that's a lot of gas to take out of that thing. So, I mean, you just got to be mindful with that. I mean, I typically tend to graph it, and if I see it jumping, then yeah, then there's probably an issue, and I need to maybe look into it, maybe add a little gas if it's bouncing like that. But again, like you said, it all depends on customer spec.
So you want to take it from there?
Yeah.
Go ahead.
So the other thing I want to say is I find this all too often is guys will look at a rack controller and say, okay, the suction pressure is set point's 42 pounds, it's running 42 pounds, but they won't throw a gauge or a transducer on there to check and see if it actually is. I mean, all too often, I mean, that's a simple thing to overlook is the computer actually displaying the proper information? I'll throw that on there, and then as I'm going through there, if I make sure my liquid levels look good, I'll graph them out if I can, and if my liquid levels are good, make sure my sight glass is clear. At the liquid shell dryers, make sure I got a good clear sight glass. If I got bubble under the sight glass, even though it's one case, I mean, if you have a pressure drop on there and you're not getting a full column of liquid out to the case, I mean, that could greatly affect your case performance. So, I mean, I find all too often guys miss that. They'll start writing up dryers at the case or PXVs or something else when you got plug dryers at the rack. So that's one thing to be mindful of, and I try to check that every time I'm in there. Just do a visual over the sight glass, make sure the sight glass isn't flashing, make sure it's clear. Um, and then just I move on from there and I'll go to whatever's controlling the actual temperature of the case, whether it be a liquid line solenoid, a suction stop, EPR, a CDS valve, electronic EPR type of valve, and I'll make sure that is actually doing what it's supposed to be doing. Making sure that like the EPR didn't lose its position, maybe the seats reset a little bit, make sure it's running the proper SST, what's on the refrigeration schedule or the manufacturer spec. So make sure that's good. And then I'll check the EPR, make sure that didn't lose its place, make sure that it's actually, if it says it's 100% open, make sure it's actually 100% open, make sure it adds suction pressure. And then from there, or if I have a liquid line solenoid, I'm checking to make sure I'm actually getting my full liquid pressure on the other side of it, because you could have a liquid line solenoid that's got a 30, 40 pound drop on it in that case. So I like to see everything at the rack running properly. Head pressure is at what the rack controller says it's supposed to be. Or if you don't have a rack controller at TD over the ambient, make sure that your drop leg pressure is not dropping too low. Make sure that that's staying at what it's supposed to be. Make sure everything at the rack is run properly and good before I move on back down to the case to start checking further into the case, superheats and stuff. Because, I mean, all too often, even if it's one case, I've seen so many times guys overlook things at the rack when there's issues at the rack and they're missing the big picture. So that's why I like to start at the case, check over a few things, and move on to the rack and make sure I'm good at the rack before I start looking at this case. And then if you have the computer and you actually have temp sensors in the case, I mean, all stores should now, but there's so many still that, graph out your case and see what the graphs have been doing the last couple of days. Look at the trends and see if it's actually defrosting, or if it's struggling to pull down after defrost, or if it's been slowly trending up, or just go from there and to see how everything else looks on. You want to take the next part of it, Brett?
Yeah, since you're already up with the controller anyway, check the defrost schedule. You can compare this to the refrigeration schedule. Preferably check the IOM from the internet. I've found in the past you can have some discrepancies with as far as the defrost schedule and the proper SST per the refrigeration schedule per the actual manufacturer. So preferably just double check to make sure all the specs that are actually on the refrigeration schedule are in fact right. Make sure that your case temperature's accurate. Sometimes you might have to have someone with you to do that, because by the time you walk downstairs by 2 or 3 degrees. So that's another thing you should be checking once you verified everything. Back to checking back to checking the defrost schedule. If you are looking it up on the internet, sometimes less information is more. Example, if you have a Hill Phoenix case and the case model number is an 05M-12-NRG, leave the 12M, leave the N, and just look 5VM. That goes Husband cases, that goes with the Kaiser Warren cases, all the footage of the case out, because that's not the true blue bottle number. That's basically just the footage of the case, which will throw. And once you verified your temperature sensors, you're going to check to see how the frost pattern is on the case. See if it's actually iced. If it's just iced, if it's that might be an indication of possibly a defragile issue. If the case is only maybe halfway frosted up, that might be an indication that you have an issue with your typical medium temp cases are supposed to have 6 to 8 degrees superheat, 3 to 5 degrees for low temp. If your superheat is off, think about it. You're not basically feeding enough refrigerant. You might only be utilizing a quarter of the coil, a half of the coil. And so now you're relying on that whole case to basically refrigerate that whole space. Checking your filter dryer. I'm a big proponent. I don't like, some people say, 2 to 3 degrees drop across filter dryers. If you really have like any more than a degree across that dryer, cut it out. Checking your screens. A lot of times with doing the visual inspection, you can kind of see what is really going on with the feeding of the expansion valve. Typically, if you have a distributor in the system, you'll see if you have a restriction in the system, you'll start expansion valve or before the distributor. Under normal operations, if there is a nozzle in that distributor, you should be having frost at that nozzle. You shouldn't have it before. Right after the expansion valve, you have a perfect harmonious mixture of liquid, and that's why it's not frosting up. Right at the nozzle is where it actually starts boiling right there. So just that's a hint to what to look for. Visual inspection, also making sure that you're in the right location, making sure that your power head is correct. You might have someone might have put a low temp power head on a medium. The notations for Sporland's power heads, C is for commercial charge, which I believe is for 50 degrees to -10 degrees. And I think low temp is from 0 to -4. So make sure right power head in for the proper application that you're utilizing. Make sure that your proper airflow, making sure by looking at the IOM manual, they will tell you exactly how many feet per minute you're supposed to have. They used to make a tool called an Alnor Junior that checked your airflow for the feet per minute. They no longer make that tool. The only thing that I found that's comparable to that is the Testo 410i. That will actually measure the feet per minute coming out of the case. In the IOM manual, it'll actually tell you that you have to check it directly after defrost, after the coils are clear, though. You can't check it midway through operation. So if the defrost is 6 times a day, you can't check it towards the second or third hour, because otherwise that frost is going to restrict, it's going to throw your airflow up. Make sure that you are checking it directly after a defrost. Making sure down case that you do have the proper suction pressure. This is also going to be checked while you're doing your superheat. Making sure that, like I said, the suction pressure should be within 2 pounds of what the rack is running when your EPR is at 100. I'm sorry, when your electronic EPR is at 100%. If you have a mechanical EPR, then obviously that's going to be set up with the rack, so you should have the correct time. If you don't, you're going to have to go back up to the rack and set that accordingly. Kevin, you want to add?
Yeah. A couple things I want to add to that. Like you went over at the beginning about looking up the case specs. So that should be every time you're working on a case, you need to be looking at those case specs. Because if you don't know what that case is supposed to be doing, you're not going to be able to properly fix it. So you want to look at those case specs every time. Like, I save everything in my Dropbox. So I have everything. Every time I work on some new piece of equipment, I download the manual, I save it in my Dropbox. So that way it's on my phone. All I got to do is pull up my Dropbox, type in the first couple letters. It pulls it right up on my Dropbox. I can look at everything. I know the case specs, defrost, airflow. If it has it, Husband, you have to actually call them for airflow numbers. So they don't put it on their IOM like Hilton does. So that's one thing to be mindful about. So if you need to get airflow specs from Husband, you need to actually call them. And just like Brett said, leaving off the NRG stuff. Same with Husband, with like some of the U's and stuff. You got to look up different. There may be a D5 case, and there may be a D5 XL case or G case. So you need to make sure you read the right manual for that, because it actually does change specs slightly on those. So just pay attention when you're doing those last couple letters of the Husband model number, where if it's a U or something, that does make a different case. So once you get that, you're supposed to be working on that. Yeah, like Brett said, I'm the same way. Like, I don't want to see any temp drop across the dryer. I've also seen dryers with 0 temp drop and a 10, 20 pound pressure drop across. So it just depends on the ambient and area that it's in. So and how much that valve's feeding. I've seen dryers that are plugged, and I've seen the strainers be plugged also, and then there's not very much temp drop at all. So it all depends on how much the load is on the valve and how much it's feeding. I am a big proponent of not having dryers in cases. And as long as that it's not customer spec to have it in there, I'm cutting that thing out and putting a piece of hard copper there. As long as my TXVs have removable strainers, I'm a big fan of just having removable strainers because at 2 o'clock in the morning, just like everybody else, I'm not wanting to pump down a case and start cutting out dryers. So I always try to, if there's just strainers in there, I'll just cut out the dryers and just clean the removable strainers. And one thing I'll just tell you guys, do not pump down a line and cut one dryer out. If there's 4 cases, do the dryers on all the cases. Because what's going to happen is you're going to fix that case next to it is going to have a slightly plugged dryer. You already pumped it down. You already had it down. You might as well change them all because if that one next to it has a slightly plugged dryer, you go through and you get the superheat right on the case you just fixed. Now that case is going to be out of balance with the other case. It's going to be running colder. And if it's on an EPR or electronic EPR, you're going to end up having one case that's with its medium temp popping the low temperature alarm while the other ones are running high. So if you got it down, just do the dryers on all of them or cut them out and hard pipe them. So it all depends on what your customer spec is. Me personally, I'd rather not have dryers in cases. I think they cause more problems than they're worth. I think the dryers at the rack are a little bit easier to control. And I mean, guys, it doesn't mess up you guys as much having the dryers in the cases. I mean, I'd rather just clean the TXP strainer. So what's your thoughts on that, Brett?
As far as betting out the dryers,
Yeah.
yeah, just do it. Do it like you said. Too many times where you'll have one dryer that's partially blocked up, and a week later you'll have the next one blocked up. Just cut them all the way out. Like you said, as long as there is a removable strainer. No, see, yeah, that's one thing. So that like there's some electronic expansion valves that don't. Well, okay, most electronic valves do not have a removable. Is there a serviceable strainer that works well? That's 3/8 that you can install, and you don't have one that's serviceable, so you can just cut it out.
I have not seen one, but like the last 5 COP startups I've done had the old Sporlan valves with removable strainers on them. So they actually took SBQE like style strainer with the right angle, and they put that in the SER or SER valves now. So you could order an SERC or SER AA. You could order that with a removable strainer, like a standard balance board valve would.
Yeah, they just take
So
long.
yeah, they just take longer to get. I mean, actually, like this supply house on my house is like starting to stock them. So they've actually started to stock them. So they're taking less and less time to get. But there's just a huge demand for them right now. So I would rather have the removable strainer. And same thing like Brett said, like the airflow stuff. You just want to be real specific with that. I know like when you start talking like manufacturers, they want to see like a cup basically on that meter because they say on theirs they're using a airflow flow funnel base to get more of an accurate reading. To be honest, I made one of the Dixie cup before, just cut the back of the cup out, shove the Testo air meter in there. That's the same. Brent has the Bluetooth one. I have like the one where it just reads on the screen. So I mean, it's the same sensor. But Testo makes a great airflow meter. I have the Alnor Junior. It's almost dead nut on with the Alnor Junior. So you just can't find them anymore. But I make that airflow cup, and then I'll stick it up in the honeycombs post defrost, and then I'll check the cases to make sure that I actually have good airflow. And I want it to be almost spot on. If it's not, I mean, there's a lot of these cases out here, especially doing startup. There's more times than not, like cases come out with the wrong fan speed program in, and these programmable motors. And I mean, the last startup I had to do 10 cases. I had random cases that were running slower than others. So I wasn't getting my TDs off those cases. Even with good superheats, I couldn't get my TDs. So that's one thing to keep in mind. And when you're changing fan motors, please pay attention to the fan motor you're putting in there. Make sure it's the same or better specs, and make sure that it's not sticking higher or lower in the fan plenum, in the actual like cup of the fan plenum, because that's going to extremely throw off your airflow. I'm of the rescue motors. I think they're the EC 5411Es.
Yeah, that's right.
Yeah, it's been a while since I looked at one. Those motors pretty much can basically take care of just about every case motor we use. I mean, I have a couple watt motors in my truck, but I probably have 7 of those motors.
The one thing about those rescue motors, there is, they so the GE rectangle motors, those aren't the actual right height for the rescue motor. So they actually sell a plate that actually goes on the back. It shows you actually on the box. It's around is the whole diameter of the motor, and probably makes it stick up probably about 3/8 of an inch. If you don't have that plate or you don't stock that plate on your truck, you can use washers to raise it up to make sure that it actually is sit. Like, and that goes the same with using a 4-watt motor versus a 9-watt motor. The difference, besides obviously the wattage, same RPM, same voltage, but the height of the motor. A 4-watt motor is going to be shorter than a 9-watt. So make not that you have if there's a 4-watt motor in there, don't just throw a 9-watt in there, because like Kevin said, it's going to end up throwing off your airflow and causing that case potentially to ice up, because it's not going to be able to push that airflow all the way around. It's basically going to short cycle that air around and lessen the amount of air going out towards the honeycombs, which is going to lessen the amount of air curtain, which is going to allow for more infiltration. Remember, most of these cases are what they refer to as type 1 cases. They're only made for 75-degree ambient and 55% relative humidity. If any one of those specs is above a higher humidity or a higher temperature, you are way more susceptible to ice up. Years ago, when the cases had less fins in the coils, it wasn't that severe. You could be a little bit higher in humidity; it really wouldn't affect you all that much. But as we got more efficient, we had more fins per inch to make these coils more efficient. They're extremely susceptible to higher humidity and higher. So if you have multiple cases that are icing up at a store, you got one set icing up one day, one set icing up another. Make sure you're checking your humidity and your temperature, making sure, if you do have excessive frost, usually what will happen is the graph will be straight across, holding temp. And then all of a sudden, probably about an hour, maybe half an hour before the defrost, it'll start spiking up. And then you'll see, once it does go into a defrost, where normally it would start going up in temp, it will start going up in temp for a little bit, and then it'll go back down and then back up. And that's typically because the airflow at that point has punched a hole through the defrost, through the frosted coil, and then start using that frost to re-refrigerate the coil. So if you see jumping around air temperature sensors before and after defrost, that's typically showing you that you have frosting on your coils.
Yeah, that's another good point to bring up, right, is the humidity, especially with the newer stuff. I've seen guys where it's super humid in the store and they're trying to send superheat to medium temp cases. I mean, guys don't really realize how much of that coil how much the load increases on that coil, especially like high efficiency coils. When the humidities and dew points higher, more of that coil is being used for latent heat removal, transferring that humid air into water vapor, condensate, and then rolling off the coil. I mean, that takes up a large portion of that coil, and then it eats up our sensible heat that we're getting. So I've seen more times than not guys working can't get meat cases down to temp or whatnot, and then you look over and I mean, the stored humidity is like 65, 70%. I mean, that right there is just increasing the load on the cases tremendously. Not to mention it's going to be causing ice ups and frost overs, everything else. But I mean, I'm a big proponent. Like sometimes, I mean, not every time, but if they have, I want guys to get up on the roof and check the dehumidification units, especially if it's a Munters. I mean, when those things work, they work good, but they usually only work for like a month, and then they're usually broke again. I mean, those things are down all the time. No matter what you do to them, they're just very problematic units. So I want guys to get up there and check because I would rather guys catch a dehumidifier and acting up during the week than somebody be there at 2 o'clock in the morning with 32 feet of meat cases iced over. And one other thing I want to bring up with that is if you're using electronic EPR, especially with these new cases, you're going to be wanting to use pull down percent. Inside the controller, there's after defrost pull down percentages where you could lock that valve, say at like 20 to 30%. Now, I tend to try to use pull downs in just about everything if I can, as long as it's not the customer specific view. Because two things, it'll solve overshooting issues. Like if you have like cases overshooting after defrost, they're real warm, that valve opens 100%, that case gets cold real quick, and it overshoots, and you got one case running slightly warm, one case hitting the low alarm. So I mean, it'll solve that issue. And then it'll also solve issues with you opening up 100% right after defrost. That coil still got a little bit of moisture on it. And now you're hitting a rag suction pressure. And if the rag suction saturation temp is pretty low, I mean, you may start to freeze all that moisture on that coil and start to frost over the coil. So I tend to like to put like 20 to 30% pull downs for like maybe like 20-minute, 30-minute, half hour, depending on what it is. So that way it doesn't frost over the coil. The other thing it does, it kind of lessens the load on the rack because post defrost, now you got this hot pressure suction gas that's trapped in this coil that's been defrosted. You may have 150 pounds of pressure in that line. If you slam that valve open to 100%, it's going to end up forcing a compressor or two on. It's going to increase your suction pressure. So instead of putting all that load in the rack, if we open that valve, say 20, 30%, open it slowly, we may be able to pull down with what we have, maybe stage one compressor on or an unloader on. So that way we're not just slamming the rack on and off at your every defrost. And the more consistent you keep the rack, the better. So it helps save energy and helps save wear and tear on the rack. What's your thoughts on that, Brett?
No, I totally agree with it. Um, preventing potential flood back, preventing overcycling on the compressors. You're only really supposed to have 10 cycles per hour on the compressors, max about 240. Any more than that, you start causing a whole bunch of wear and tear on everything. The starters, the compressors, vibration. You're causing more wear and tear than what it's worth. So the less amount of big impacts on the rack that you can cause, the better. One thing I forgot to bring up, if you do have a lineup that is completely iced over frosted over, and you're trying to, instead of having to get out the hose and de-ice 40 feet of medium temp lineup, if you close the suction line ball valve and let the liquid line feed, you're essentially bringing more pressure into that case. And obviously, we all know PT charts, the higher the pressure, the higher the temperature. So if you continue to let that feed, you'll basically raise the pressure in the suction a lot faster. And then basically de-ice the coils a lot faster. Just like Kevin said, though, when it comes time to open that thing, just make sure you do it slowly. One, so you don't overload the rack. Two, so you don't cause a whole bunch of short cycle in the compressors. And three, to make sure that you don't flood out your rack.
Yeah, that's a good point. And the other thing I would like to bring up is like going to like product temp issues. So a lot of calls, you make good discharge air temp in a case. You could have perfect discharge air temp in a case. Say it's 32 degrees and that's the spec. and you could still have 54-degree product. So this messes up a lot of guys. And after you make sure the case is running properly, what you're going to want to do if you have product temp issues is take a look at the case, how it's set up. Does the case have the proper shelf length in there? You can find that in the manual. I see all too often you get these reset teams come in there and they're just putting whatever shelves they find in the case, or this shelf looks good. It may require 17-inch shelves in the case, and you got 20-inch shelves. Now that product's out of, it's in the air band, or it's out of the case, out of the air band, or it's disrupting the air band, which is going to cause warm air from inside the store to come inside the case, and it's going to cause the case to run. It may cause the case to run warm, or it's going to cause the product temp to be warm. One thing to be mindful for: do you have the correct shelves? And then everything new now seems to be these pushers and these pegboard shelves. So everything with pegboard and pushers, all these aftermarket shelf setups, you have to have a plexiglass fake shelf underneath of the pushers. Even if the pushers are solid bases and the pegboard, you have to have a plexiglass fake shelf that goes all the way to the back wall of the case. Now, this simulates a proper shelf for proper airflow. If you do not have this, what ends up happening is the air flows down the back wall of the case, or it starts spiraling into the case and ends up washing out the air curtain. Hill Phoenix has a really great example of this inside their case IOMs. I'm pretty sure it's just about every newer case IOM. There's like a page or two where it shows like the air swirling around inside the case. I mean, it's something I would take a look at. I mean, the greener guys, so they understand this, but you're going to want to make sure like you have a fake shelf on those. I see it all too often. The front side of a pusher you'll be running warm. And just because that case has been like that for 8 years doesn't mean there's not been a problem the entire time or is a new problem now. So don't look at something just because it's been there for a long time or it's been this way for a long time. That's not a problem, because it's probably a problem and nobody's ever caught it or done anything about it. So that's one thing to be mindful of. So make sure you have the proper shelves and a proper shelf setup. And same thing for angled shelves. A lot of manufacturers, especially Hill Phoenix, on their meat cases, they have these clips or these shelf extending brackets on the back of their shelves. And if they're on an angle, there's actually like a 2.5-inch gap between the back of the shelf and the back of the case. And there's these spring loaded L brackets that you have to cut zip ties off of. And what ends up happening is the standard guy doesn't go around and cut all those zip ties, or the carpenters when they put the shelves in. And those shelves are going to have like a 2-inch gap, and that cold air ends up falling down the back wall and then goes down to the bottom of the case. And then you don't get that shelf temperature so that you need to get. So that's one thing to be mindful of when you're looking at stuff. Make sure your shelves are proper. Make sure your product's not sticking out of the case. Make sure your return air grates aren't blocked. Make sure your suppliers aren't blocked. Make sure that you have proper shelving. And then another thing that I see guys miss a lot, and I just found one on a store that's been open for 15 years, is, I mean, they finally got audited by the health department on this certain case, and the heat was running, and there was a vent blown in the case. One thing to be mindful of: you hope it gets caught on startup. Make sure the HVAC vents aren't blowing into the case. I mean, I'd seen vents be 40 feet away from a case, 40, 50 feet away, and they're washing out a case. I mean, some could even be farther. I mean, it's just a little bit of air blowing that way is enough to interrupt that air curtain. So you want to be mindful of that. Make sure you're not washing out the case. One easy way to test this is old school ways with a smoke pen. You light it on fire and you could smoke out the case and you could see if like the air is getting washed out, if it's not making it back to the return. So that's one way to check it. I just typically tend to use like toilet paper if I think something's blowing in there, like see if it'll move the toilet paper. And then I'll just redirect the HVAC vents so they're not blowing in the case. So that's one thing to be mindful of, especially if it's like the first row product that's causing an issue. I have a thermal imager. They've come down a lot more. Like Flare makes a way cheaper version of like I think it's a TGI like ones. I think you have it right, Brett.
Yeah, I think so. I don't remember the model number, but I mean, if like I think about a year ago, I paid like $350 for.
Yeah, it's 100% worth it. I mean, for finding out issues like this, I mean, product temp issues, like and you could show a customer right then and there, like, listen, this is a pusher issue. You look, scan the case, and that 4 foot section of pushers may be the only one that's warm. Well, that's the issue. So that's one thing you guys got to remember is you could have perfect discharge air tap, but have 44-degree product temp. So that's one thing to be mindful of. You got to make sure that case is set up the way it's supposed to be. Because if you call that manufacturer for tech support and you tell them that it's got pushers, they're automatically going to blame the pushers because it's out of their design. So just keep that in mind before you tell them that it has pushers. Make sure you get all your specs, everything right, and make sure your false shelves are there, and make sure nothing's blown in there. And then make sure, like I've been seeing a lot of D-strat fans, which are like fans up in the ceiling of the up high by the ceiling, de-strap by the air, basically to move around the air that's stagnant up at the top of the ceiling down the warm air, blow it down sales floor. So it also warms the sales floor up, keeps HVAC zones more comfortable and more even, and then it also helps save some energy, keeps the HVAC from cycling so much. But they seem to put these right in front of every multi-deck case they could find and usually pointing right at it. So like I don't know how many D-Strat fans at the last two startups I did, I had to either move or get extras for to move or just turn off because they're blowing into cases.
I'm thoroughly convinced that the engineers, when they're making the plans for the supermarkets, they're like, where can we put the discharge air vents? Where can we put the destratification fans that's going to screw with the refrigeration guys the most?
Oh yeah, 100%. Like I'm so tired of moving vents and everything else. And usually the HVAC contractors wants to be no help because they're working off the prep, which I get. They're working off the prep. Then it just turns into this finger pointing contest. So that's why some stuff like that doesn't get fixed. I mean, some service guys gotta understand, like it may not be the startup guy's fault because um they may not want to pay for it. And then they're gonna pay for it double down the road.
Change order.
Yeah. Change orders. You got anything to add to that, Brett?
Yeah, sometimes you'll also have the condensation fans are strapped in the back of the cases that basically move air from behind the case out from underneath and vice versa. Usually these fans are blowing upwards, and so it's sucking air from the floor, pushing the air up to get rid of a little bit of condensation that might be forming underneath the cases because you have drains down there. You have that basically are putting a little bit of humidity up there that are underneath the case. So the idea is to get that humidity out from underneath there. Problem is sometimes they also are blowing in the opposite direction, especially if the fans are up against the wall. They don't want to dirty up the wall. I had an instance where they had this done, and I had been working on a case for 2 days trying to figure out, yeah, my discharge was at 28 degrees, but the product was at 40 and it didn't make any sense to me. I'm switching around plenums. I'm switching around fans. I'm checking speed on fans. I'm double, triple checking superheat, making sure all the cases and the case shelves are at the proper distance, making sure they weren't out and protruding into the load limit line. I accidentally dropped the piece of paper and watched the piece of paper flutter across the floor. And I was like, whoa, where's all that air coming from? And it was because the air was blowing so hard down the front of the case. It was really going in towards the front and causing that product temperature to be elevated because it was adding such a load into the case. You were talking about some other cases where you have to watch the load limit. You were talking about the angled shelves as well as the peg shelves. Those also do add BTU load to the cases. For every row of peg shelf or every angled shelf. A lot of times in the manual, it'll actually tell you every 4 foot section, it adds 92 BTUs per 4 foot section. So be mindful if you have two cases that are running just fine and you have another case that's struggling and you find that there's lined up with a whole bunch of pegboard or lines up a whole bunch of angled shelves and you find that it's running a higher superheat and there's no explanation why. You might have to do a load count on that case and figure out, is the expansion valve size for all those angle shelves that they put in there, or is it not? Some of the older cases in the dairy, they're called rear load dairy. Usually there's a little alcove in the back, 6 or 8 inches, and with a door in the back. And those doors are meant so they can load the product from behind, so they can put the newer product behind and basically push the older product towards the front. Those alcoves that are usually, 3 foot by, like I said, about 6 inches deep, 6, 8 inches deep. If there is not a shelf extender in toward the back, the fact that there's holes on either side of the walls of that little alcove as well towards the top, if the shelf extenders are not in there, what'll end up happening is, just like with the angled shelves, the air will just flow directly down to the lowest part of the case and basically make the product on the lowest shelf super cold. And then all the rest of the shelves, you will have the proper discharge air coming out of your honeycombs, but then you also might have a shelf temperature of 36, 40 degrees. And it's because that air isn't actually going across the product originally intended. So I don't know. Do they make? I mean, you do a lot of startups. Do they still do rear load dairy or not? Some
Yeah, I mean, it depends on the customer. Walmart still puts in a lot of reload dairy cases. So, I mean, they're still doing it, but it just depends on the customer. So I'm still seeing them. I see them less than I did before, but you still do see them. And one thing with those reload dairy cases, you need to make sure is a dairy cooler working properly? Because if a dairy cooler's not, if it's running warm 38, 39 degrees, I mean, that's going to add more load to the cases too. Because I mean, those doors are insulated, but they're not that good, not that great. So you want to make sure those coils are clear on the back of the dairy cooler because they cuddle on a cardboard up in those walk-in dairy cooler coils always seem to get cardboard dust all over the back of the coils. You end up not making temperature because the whole back of your coil has no airflow. One thing I wanted to point out, like with what you were talking about earlier, with I forgot to talk about this. If you're if you're making discharge air tap and you're having product temp issues and you're checking airflows and your airflows are kind of crap, one thing you want to make sure is like I always shine my light out there and check the honeycombs. I mean, there's times you look at cases they haven't had the honeycombs cleaned in 8 years. I mean, they will just be absolutely filthy. So, I mean, if I'm working on a case, especially if it's been a problem case, like I'm gonna pull those honeycombs. It's easy work. I mean, it's fill-in work just to make sure you get your hours and whatnot. I mean, if it's slow, but I mean, I'm looking for honeycombs to clean because they're usually dirty and making sure that there's no brackets in the back, that baffles in the back. Phil Phoenix is notorious for putting baffles in their cases. So in the back, airflow baffles in the back walls to make sure those are actually clear and clean. I mean, you may have to pull them apart and clean them. Make sure the coils are clean. If you're having airflow issues or product temp issues, make sure your coils are spotless clean. Hill spaces are notorious for it because their coil spacing is so tight. Make sure that everything's properly on those, properly cleaned and set up, and fans are all going. So that way you actually have good airflow. And then one other thing to check on the husband cases with the individual coils, I see this a lot. Every once in a while, you see it on Facebook, is the back walls tend to cave in a lot from people pushing too much product in there. And you will actually have food fall from the back wall onto the top of the coil, and it'll restrict the airflow going through the coil. I mean, I pulled one out one time and found a couple pieces, packs of bacon that were like 6 years old. That was absolutely disgusting. I mean, same thing with hot dogs. I think those go bad. So that's one thing to check. I mean, make sure you absolutely have airflow. I mean, somebody could have fixed the back wall and just not throw the product out.
Once you're figured that you got everything cleared out of the coil, just make sure that coil, as far as the product, make sure those coils are completely clear of any ice or frost. Too many times, guys, technicians, they're spraying the coils and not actually taking the back walls apart, not taking the actual plenum out. You have to make sure the cases are fully clear of any ice, or you're going to be back there. It may not be tomorrow, may not be in 2 days, but you'll be back there. I promise you.
Yeah, that's one thing, and I mean, it just burned me the other day. I had somebody walk in there every week. They checked the coils and they looked at the back of the coils and they had a little bit of ice and it was a little bit of ice. And okay, yeah, we're fine with a little bit of ice. We could deal with that. And then come to find out, the entire front of the coils were solid blocks of ice. So that's one thing to be mindful of. You need to check both sides, especially on walk-in freezer coils. I've seen that they changed up a lot of the way that the coils are circuited here lately, and the front of the coils seem to ice up more now. So that's one thing you need to be mindful of is actually checking that. And then Hill Phoenix cases, frozen doors, I mean, are absolutely terrible to de-ice. Everybody knows that, especially the electric defrost ones. So one thing to be mindful of how I show guys to do it. So I do it two ways. I either use Harbor Freight magnets, like really strong magnets to hold up the back walls. So what you do is you take the back wall, stick a screwdriver through it, pull the back wall again, and you put the 100-pound magnet on there, right on the shelf, and it'll hold the back wall up. Or you shoot self tappers in the shelf rails and the back wall on each one, so that way it holds up the back wall, so you could actually pull the top coil cover off. Because if you don't pull that thing off, that coil is only exposed like 5 inches. It's back there another 8 inches. And I've seen time and time again where guys de-ice what they think they see, and then that coil's another 5, 6 inches back there, and the whole backside of the coil still has a bunch of ice on it. They de-ice it and think everything's fine, and they leave, and somebody's back there, and like 2, 3 weeks later after it loses airflow again.
So do you want to talk about the medium temp cases and how they're supposed to defrost?
So medium temp cases should be off time defrost for the most part. Certain customers use hot gas for all their medium temp cases. I mean, I don't think that's necessary, but that's just how that certain customer does it. But you will find neat cases with electric and hot gas. Most of the time for medium temp, we're going to be doing off cycle defrost. So that's either going to be shutting off the liquid flow. Not my preferred method of it. It takes way longer. I would like to use a suction stop if I'm doing it. So meaning an EPR with a suction stop solenoid or an electronic EPR. So we're backing up all that liquid refrigerant, and you're backing all that suction vapor up in there, and it tends to help aid in defrost because now that liquid has mass to it, and it's going to warm up and then help defrost the coil all the way through. It's going to warm up in the tube. Eventually, it's going to aid with a little bit of defrost. So that is how we're doing off-cycle defrost. One thing you got to watch out for is when you're doing termination with discharge air temp, especially on medium temperatures, is what tends to happen is if you don't have enough defrost time and where the temp sensor is, the middle of the case tends to thaw out before the ends do. So if you see a case if your humidity's good in the store and you see a case where like the center of the coil is clear, but the left and right hand side has got more ice, more frost and ice, you may have to extend your minimum defrost time a little bit, or raise your term temp up a little, or not terminate on case temperature at all if you're not defrosting on the ends properly. So I don't know if you've seen much of that.
Yeah, typically I like to see the case termination on min. So basically, it's going to take the lowest case temperature and defrost off. Because if you do average, one might be 60 degrees, one might be at 30. Well, the average of that might be right at termination temperature. So you have to, preferably, I like to always see it at min. If you have a case set up where it's average for the case temperature and it's actually using the same average to terminate it, sometimes what you can do is you could do another program the case for defrost termination sensors, and then basically just copy the discharge air ones and tell the defrost termination sensors to actually be min. Usually, if you have a conventional parallel rack where you have the liquid line solenoid and the electronic EPR or mechanical EPR, you want both those valves to shut off because you don't want to have intermittent liquid level. But throwing a whole bunch of liquid in the lines. You might stow 250-foot worth of pipe of refrigerant out into that case. And so, like we said before, with opening up the EPR, the mechanical EPR, when that case comes out of defrost, you're going to have potentially a large quantity of liquid coming and flooding out your rack. If you do have a loop system where you actually have a suction and there's a suction stop or an EPR and solenoid at the case, it's not as imperative to shut down the liquid line solenoid, because basically the EPR is going to be right at the exit lineup and be all the way back at the rack, storing, like I said, 250, 300 foot worth of refrigerant out into the system. Go ahead, Kevin. Sorry.
Yeah, I completely agree with that. You want to go through and do it. I wanted to go over one thing I just remembered about that. Earlier, we were talking about making sure the power heads are right, and you were going over the charts. I completely slipped this, and I forgot I wanted to throw this in here. So, a couple things with that. So, on husband cases, on especially all their frozen food doors now, they are coming out with C charges instead of Z charges on all their frozen food doors for like the last like 2 3 years. I think they've been doing it, unless it's customers the other way, because they're actually getting better results out of using a C charge. And then what ends up happening is a lot of these doors are getting used for dual temp operation. So being used for medium temp also. So with them using a C charge, they're still able to hit the low superheats required for low. And then they're also still able to hit the keep stable superheat for medium temp better. So if you see a C charge in a freezer, I mean, it's still gonna work. I mean, it's good down to -10, like Brett said, but I mean, it's not the ideal application, but it's not the reason your case is gonna be running warm. So I don't know, have you seen those, Brett?
No, actually, I haven't.
Yeah, like we just did a bunch of glass door changeouts for the last 2.5 months. I've been starting up a lot of glass door changeouts. I think out of like 11 stores we did, every single husband came out with C charges, and then like the last couple startups for the last couple years is they've all been C charges.
Well, it could be too that stores are starting to try to raise the temperature of their ice cream. Years ago, they used to do -12, -15. Now they keep raising it up. Some stores that we have only keep their ice cream at -8, -6. So obviously, you don't
Yeah, I mean, that's my
lower
set
that's
points.
the uh,
If I'm commissioning a store, like I'm putting the ice cream at -8. There's no reason to run it at -12 or -10. I mean, that's just wasting energy. The last thing I wanted to go over was actual like superheats. So we'll make this real quick, and then we'll start to wrap it up. So the actual superheat. So if I'm setting superheats like for low temp, I'm shooting for like 3 to 5 degrees, and for medium temp, I'm shooting from like 8 to 5 degrees. The lower you can get that superheat and keep it stable, and just make sure that that low swing 0, or make sure that low swing not hitting. I try to aim for my low swing, so valve swinging low to like 3 degrees, up to like 6 or 8. I'm happy with that. Like I'll take that. The lower you get that superheat, the more flooded out that coil is, the more efficient that coil is going to be, and the higher you could raise that suction saturation temp to get that case to run more efficient. So you want to get that, you want to have those colder temps coming back to the rack so you can maintain that 20 to 30 to 5 degrees of superheat at those compressors, because that's going to make everything run more efficiently, and everything's going to run a lot better. You're not going to break down oil. But my targets for superheat are, unless the manufacturer sends something different, are 3 to 5 for low temp and like 6 to 8 for medium, or like, sorry, 5 to 8 for medium temp, depending on what I'm working on.
the only exception to those rules are coffee case, whether it's in medium temp or low temp. Hill Phoenix and Husman like to maintain 3 to 5 on their bunker cases. The other exception to the rule are low profile heat craft evaporators. Now, when I talk about the low profile units, I'm talking about the evaporators that have 2 coils and the fans directly in the middle, where they're basically the fans are pointing down. You try to set them for 6 to 8, you're gonna end up starving out one side of that evaporator coil.
Yeah, I used to see that a lot. I mean, a lot. So I do another thing on those coils. You need to make sure the distributor's pointing down, or else they won't feed properly either. I've seen the last couple startups I've seen distributors coming out sideways, and we actually had to bend them down and use a street 90 to go into them to actually get them to point down because they seem to not feed properly unless the distributor's pointed down so it can feed off the sides.
Every single one I get of those, they're all pointing sideways. I think that's why Heatcraft wants you to have the superheated 3 to 5, because by flooding it that much, you're basically getting the full column of liquid to that distributor.
Yeah, I mean, it's probably doing the same thing. We were actually putting these together from the beginning, so I mean, they didn't have valves mounted in them, so we ended up just pointing them down. I think it works a little better. So I mean, but I obviously, if you're not gonna you pump the thing down, that you could just flood the coil out. So, well, I think that's gonna be a wrap on this one. I think we covered a lot, and this will probably end up being a two-part episode. We'll probably add on more to this as we go on with maybe some more walk-in troubleshooting, and as we break down, and we're gonna go farther into the rack troubleshooting, and then I think next couple episodes after this is gonna be about oil. It seems like most guys want to get into the oil systems.
It sounds good to me. We'll get into the low temp. We touched on some low temp case diagnostic, but we'll cover that a lot more as far as how the operation is supposed to go, sequence of operation as far as defrost, fan termination, all that other stuff on the next one.
All right, guys, have a good night.